Hello and welcome to this live demonstration of the Respondent pilot. Thank you for joining us today. I am Andreas Tsarouchas from Future Intelligence, the front-end developer of the Respondent solution, and I'm excited to introduce and walk you through the demonstration today, which will be focused on the power generation forecasting module of Respondent. I will walk you through the demonstration through the module's dashboard, a web-based user interface showcasing the module's core functionalities and innovations. Before we start with the presentation, I would like to refer to the responsive design of this module. So the primary use of this solution is designed for web application on desktops, as it provides a comprehensive dashboard experience best suited for larger screens. While the app is responsive and can display properly on tablets, it's not recommended for use on tablets or phones due to the detailed nature of the interface, the amount of data displayed, and the complex interactions with the graphs and charts. The dashboard's layout and functionality are optimized for desktop environments, allowing users to fully engage with the app's key features and analytics and offering a better user experience compared to using it on tablets or other mobile phones. So as we can see here, this is the login page of the Respondent solution. And the user, whether a renewable energy source owner or an aggregator or an administrator, enter their credentials, and upon successful authentication and authorization, the user gains access to the solution's features and functionalities. And as we will see after the successful login, the user is automatically redirected to the weather forecast module. So let's log in. And as we can see, as part of the power generation forecasting module, we have the weather forecasting component. So this component is responsible for monitoring both forecasted and real-time weather data for the specific photovoltaic plant. The forecasted weather data is generated using a combination of the following sources: the Copernicus Earth observation data, historical and real-time data from local weather stations, and historical and real-time data from the photovoltaic plant. These data inputs are processed through our weather forecasting models, which generate prediction for pressure, air temperature, air humidity, solar radiation, and cloud cover, which then are displayed in the following cards or components, to say so. So the cards is this plant's detailed cards right here, the live data, the pressure, the air temperature, the solar radiation, the cloud cover, and the air humidity. So for the plant's detailed card, this card displays all the essential details of the plant, including its name, its status, either it's online or offline, and size with respect to the park's energy output. It also features an interactive map right here, as you can see, allowing the user to view the plant's actual location, zoom in or zoom out, and click on the plant's icon to see again the name and its status. Additionally, there is a home button that reinstates the map to its original position and focuses on the plant's location. And you may have noticed that the language in the map is not English, but that depends on the end user's browser and its local language preferences. That means that the map will be rendered using the language in the current user uses. So next one, there is this live data card, and this card displays the latest real-time data from the local weather station in a table format. Also, the table includes the sensor type, if it's pressure, air temperature, solar radiation, cloud cover, air humidity, the current values for each sensor with their corresponding unit, and the timestamp of the latest real-time data update. And as you can see, it's live right now. Next one, moving to the attributes card. As we said before, each attribute card contains a graphical representation of both forecasted and real-time values. The x-axis displays the timestamps of the current day in 1 hour intervals, while the y-axis represents the attribute values. The forecasted series is divided into two parts, past and ahead. Past refers to the forecasted values from the start of the day up to the current time when the user is logged in and actually using the solution. and ahead refers to the forecasted values from the current time until the end of the day. So for the graph functionalities, we can zoom or select a specific time frame to zoom into and see in more details the values of the series. There is a home button on the top right corner that resets the graph to its initial state. As you can see, all graphs are synchronized, so when hovering over a timestamp on one graph, the same timestamp is displayed across all the graphs. And there is a hamburger menu, which gives the ability for the user to download separately the graphs into and SVG, PNG, or CSV format. For the data extraction, on the top right corner of the screen, you can see there is an export chart data button where the user can select and download all of the graphs data into one file, choosing between an XLSX file for Excel and CSV format. The data in this page is set to refresh automatically every 1 hour. So, as we can see, the weather forecast data is key to determine the power generated. And now we will move on to the power generation forecasting module through the user dashboard. So, the power generation forecast module. This module consists of three cards. The first one is the plants card. Again, this card displays the list of all available photovoltaic plants and their status, online or offline. It could be the case that there will be more than one photovoltaic plants, and this would be depicted here in a list format. The power generation forecast card. So this is the main feature of this page, and starting at the top right of the page, you can see a switch that the user can use to toggle the unit of the graph. The available options are energy, which displays the graphs using kilowatt hours as unit, which is the default option, and the power, uh, which displays the graph using kilowatts as the unit. So moving on, this is a small control panel, and the user can use it to interact with it. This control panel consists of two switches and a button. The aggregation switch. This switch toggles the aggregation period between hourly and quarterly. That mean 15-minute intervals instead of 1 hour. The user can select whatever he wants. By default, the aggregation period is set to hourly, with the x-axis of the graph displaying timestamps in 1 hour intervals. And if we switch to the quarter, we can see that actually there are 15-minute intervals. The 3-day ahead switch. This switch can toggle the view of the graph. On 3 days ahead, which is the default value, the graph displays the predicted values of the power generation forecasted for the current day and the next 2 ones. By switching this off, as we can see, the graph displays only the current day predictions. There's also an export data, export chart data button again here, like we saw before. From this drop-down menu, we can download again the charts data into the following formats, XLSX and CSV. So the main card, next one, this is a more critical component of this module. The header of the card provides key information about the photovoltaic plant, again, its name and its status. And in the top right corner, we can see the location, the coordinates of the photovoltaic plant. Next, there is a table presenting the performance statistics. Each row of the table contains metrics related to the predicted values from the power generation forecast, along with the respective values and accuracy indicators. All metrics are described in detail by clicking the information button located in the top right of the table, and upon doing so, a model will appear presenting all relevant information and explanations regarding the metrics. This includes descriptions of each metric as well as the associated accuracy thresholds. A more detailed description of these metrics will be provided in the next presentation. So, for the graph, this graph displays all the forecasted values of the module. On the x-axis again, we can see that all timestamps, we can see all timestamps of the selected time frame, split it on 1 hour intervals or 15-minute intervals, depending on the selection of the aggregation period by the user. And on the y-axis, you can see the values of the forecasted power with their corresponding unit. By default, the initial state of the graph uses the following: energy in kilowatt hours as the pre-selected value for display, aggregation period is set to hourly, and the 3 days ahead is enabled. The data series of the graph are the actual generation, which is the real-time data of the photovoltaic plant retrieved directly from the plant. There is the day ahead, which is the forecasted power generation values for the current day and the next 2 days. There is this past estimations series, like in the weather forecasting module. Past estimation refers to the forecasted values from the start of the day up to the current time when a user is logged in and using the dashboard. And the upcoming production, hour ahead, which refers to the forecasted values from the current time until the end of the current day. And as you can see, if we hover anywhere on the graph, and depending on the aggregation period, there is a tooltip that pops up, displaying the values of all data series for the specific timestamp. Again, the graph's functionalities is we can zoom in using these buttons, or if we select a specific time frame, the graph will zoom in. There is a home button that resets the graph to its original state. All graphs are synchronized here again. If we have more plants, we could see that they will be synchronized. And there is a hamburger menu again, which provides the ability for the user to download the graph's data into an SVG, PNG, or a CSV format. As you have noticed, when hovering the legend right here, only the corresponding data series displayed on the graph. The timeline card. Right here, we can see the timeline card, which is an interactive feature that allows user to retrieve both forecasted and real-time power generation historical data from the plant. The user can choose from three predefined time frames, which is today, that retrieves the historical data for the current day. There is yesterday, that retrieves the historical data for the previous day. And the last week, which retrieves the historical data for the last 7 days, including the current day. There is also a custom date picker, where the user can select a specific time frame ranging from 1 to a maximum of 7 days. It's worth noting here that the user can select data from the time period of when data is available. So if, for example, we would like to see the historical data of 1 year ago, we can select and the data will display right here. And last, there is the weather widget to the bottom of the screen, which displays the temperature of the cloud or the cloud cover, as in the weather forecasting component. And starting from the current time and until the end of the day, the widget displays at hourly intervals the upcoming predicted values for either the air temperature or the cloud cover, based on the selection of the user. By default, the cloud cover is selected as the attribute to display, but with a button on the top right corner, the user is able to switch between cloud cover and temperature, right here. The page refreshes automatically based on the selected aggregation period. So when the user has selected hourly aggregation, the page is refreshed every 1 hour at the top of the hour. Otherwise, if the quarterly aggregation is selected, the page refreshes every 15 minutes, specifically at the 15th, 13th, 45th, and the 16th minute of each hour. And with the weather widget, this concludes the demonstration of the power generation forecasting module we developed as part of the Respondent project. So this is the demand forecasting module. As you can see, there are two main components, the timeline card and a demand forecast card. The demand forecast card includes a map, which is an interactive feature, whereas you can see all areas of interest has been used for the power demand forecasting, can be displayed here. As you can see in this small legend, the areas have been separated into three categories: the residential with a pale blue color, the commercial with the yellow color, and the industrial with the gray color. So when you hover over an area, you can see the region name. We can zoom in, zoom out, and see more areas like this. You can also use the map zoom, and there is also a home button that centers the map again to its original position. So the timeline card right here, as we saw before, is an interactive feature that allows the user again to select a specific time frame to retrieve the historical data of the power demand forecasting module, ranging from 1 to a maximum of 7 days. The user can also select from three different predefined time frames, the today, which retrieves the historical data for the current day, yesterday, which retrieves the historical data for the previous day, and the last week, which retrieves the historical data for the last 7 days, including the day the user is actually using the solution. To the top right, there is an aggregation switch that toggles the aggregation period between hourly and quarterly. Quarterly means 15 minutes intervals. And by default, as you can see, the aggregation period is set to hourly. And when we click, for example, on the industrial area, you can see that a window will pop up containing two graphs. So as we said, by default, the aggregation period is set to hourly. So that means in the x-axis, you can see here that the intervals between the timestamps are in 1 hour intervals, and when toggling to quarter, this will change to 15-minute intervals. So those two graphs, as you can see, the first one displays the power demand prediction, while the second one, the energy demand prediction. Both graphs on the x-axis display by default the hourly time intervals for the current day, while on the y-axis the values of the series are being displayed. For the first one, we use kilowatts for the power prediction and kilowatt hours for the energy prediction. Both charts have two series, power confidence and energy confidence, and the power prediction or energy prediction. So with power prediction, we refer to the predicted values of the power, while for the power confidence series, as you can see, there are two values for each timestamp, a lower and an upper threshold of the power prediction. And the same exactly applies to the energy prediction graph. The user can also select, for example, the last week's data, and let's click on a residential area to see. Again, we can see the data for the last 7 days. We can zoom in to have a more detailed view of the timestamps of this selected time frame. Again, the user can zoom in and zoom out using those buttons. There is a home button for the graphs that reinstates the graphs to its original states. And there is also a hamburger menu where the user has the choice to download the charts data into three different formats: SVG format, PNG, and CSV. And this was the demand forecasting module. So moving on, we will move to the smart grid monitoring module. So moving on, next one, the smart grid monitoring module. So as you can see right here, this is the layout of the smart grid monitoring module. In this component, the user can have a visual representation of the real grid along with the nodes. And when we say nodes, we refer to the substations and also the power lines. So the grid is set up accordingly uh, to the main topology of the original grid, but due to privacy and security purposes, the original map is actually hidden. So on the top right of the component, you can see that there is a legend explaining the basic elements of the grid. With the red color, there are the main grid substations. With the yellow color, the subgrid substations. With an orange color, the bifurcations. With blue color, there is the PMU. And with the green color, there are the substations connected to the transmission system. So they are actually the substations that are connected to the original transmission system, and in simple words, they provide energy to the other substations by taking this energy from the national grid and sending it to the other substations at a regional level. As you can see, there is a zoom in, zoom out functionality for this grid. There is also a home button that reinstates the grid to its original position. And as you can see, there is a rotate button right here that rotates the grid horizontally or vertically if we want. So I will leave it as horizontally for a better view. On the bottom left, as you can see, there is also a legend indicating the color of the power lines according to their value of the power flow in megawatts. As you can see, actually the colors are changing uh, between intervals, indicating that the power flow has changed and its value. So let's see the main nodes, as we said, with the red color. When we hover over a node, we can see some of the node's attributes like the ID, the name, the voltage magnitude in per unit with 40 kilovolt as the base voltage, and the voltage phase angle. So we can also click on a node and get more information. So when we click right here, a window will appear on the right side of the screen containing all the above attributes of the line, plus two graphs that contain historical data. For example, for this node, there is the VM, as you can see again here, and the V-angle attributes. On the x-axis are displayed the values of each attribute with the corresponding unit. Per unit for the voltage magnitude and degrees for the voltage angle, while the x-axis simulates the order the data have been received. So the data are being refreshed every 10 seconds right here, and of course this is adjustable. Again, there is a menu, as you can see, for each graph where the user can zoom in or zoom out for more detailed view. There is a home button that reinstates to its original state the charts, and there is also a hamburger menu where the user can select and download the graphs data into three different formats, an SVG, a PNG, and a CSV format. Moving on to the lines, again, as you can see, when we hover over a line, we can see some of the power line attributes, like the name. There is a from attribute that indicates where the power flows from, and the to refers to where the power flows to. There is also the power flow in megawatt, as you can see, and the line loading in percentage. So again, if we click in a line, for example, this one, again, a window will open that contains a table with the line main attributes. And again, we have two graphs right here. while on the y-axis are displayed the values of each attribute with their corresponding unit. It's megawatt for the first attribute, and the line loading is in percentage for the second one. Again, on the x-axis simulates the order of the data have been received, and this refresh every 10 seconds, and of course again this is adjustable, just for demonstration purposes set to 10 seconds. There is also, as we said in the beginning, a subgrid with the orange color that for now we can see that the subgrid is at a lower voltage level, and that could work as the main grid once it is modeled for power flow analysis and the SCADA data are available. So this makes this module easy expandable. And for now, the only thing you can see here is the ID and the name of the substation, because there are no actual data for those substations. As you can see right here, this blinking red circle indicates that there might be potential faults or problems on the grid, and this is like an alarm feature that visually informs the grid operators about those potential faults. Moving on to the PMU, as we said, the PMU is this blue icon right here, and when we click on it, as you can see, a new window will open containing all the information about the PMU itself. At the top of the component, you can see again there is a table present with all the attributes of the PMU, such as the ID, the type, and the name. And there are also some graphs that display the PMU attributes. So in the first row, you can see that there is a chart displaying the phase voltage historical data for 3 different series, the phase voltage A, B, and C. The unit is degrees right here on the y-axis, while on the x-axis we can see the timestamp for this day, the current day. As you can see, there are also 2 polar plots showing the synchrophasors of voltage and currents for phase A, B, and C. This polar plot provides simultaneous information about the angle and magnitude for all phases of voltage and current, and it's useful to have a fast visualization of the balance of the 3-phase system. So moving on to the next 3 charts of this component. We have 3 attributes here, the magnitude current, which is displayed in amperes. Again, there is a magnitude current A, B, and C series. There is a magnitude voltage. Again, there is a magnitude voltage A, B, and C series, and the unit right here is kilovolts. And last, there is the frequency, which is displayed in hertz. Again, for each graph, we have a menu right here. The user can select a more specific time frame. Okay, see this updated. Okay, so I can select a more specific time frame to have a more detailed view. There is a zoom in and zoom out button. There is a home button that reinstates the graphs to its original state. And there is a hamburger menu where the user again can select between 3 predefined formats, SVG, PNG, and CSV formats to download the charts data.